our first example, I'm going to be given this area, x in meters, y in meters. I'm going to draw here my lovely little area. We're going to stop it at x is equal to 10. My shading is so fantastic. All right, this line is defined by y is equal to 1.2x minus 0.1x squared. I want to find inertia about the x-axis, inertia about the y-axis, and the polar moment of inertia. And I'm going to subscript that with a naught for the origin there, O. All right. Now, here's my understanding, and here's how I'm going to explain it, okay? This area is continuous along the x-axis, right? It touches the x-axis the whole time. So, my moment of inertia about the x, I want the x to be on the outside, integral y to be on the inside, y squared dy dx. Okay? Now x is the one that we have. Distances for us is going to be 0 to 10 meters of the integral of y squared dy dx. All right? Now if we integrate this first little inner piece right here, okay, the integral of y in terms of y for y squared, right, we are going to get 0 to 10 meters of y cubed divided by 3, right, dx. So this is that integral, that inner integral solved for y. Okay? Now that we have that, we have y here in terms of x that we need to plug into here. So Ix is equal to the integral from 0 to 10 meters of 1/3, I'm going to move that out, of, and I covered up my equation, 1.2x minus 0.1x squared cubed dx. And I get this to equal 83.81 meters to the fourth, right? Because if we've got area times a length squared, that's going to give us a length to the fourth power. All right, similarly for Iy, I'm going to put x on the outside, y on the inside, x squared dy dx, right? So if we integrate this inside portion right here, we are going to get 0 to 10 meters for that x length that we have of x squared y dx, right? Integrate x, which would just become a constant in terms of y. Okay, and then once again plug in the y equation in terms of x. So this is going to equal 0 to 10 meters of x squared times 1.2x minus 0.1 x squared dx. And when we integrate that, we will find that Iy is equal to 1,000 meters to the fourth. Polar moment of inertia is very simply adding those two together. So that will be 83.81 meters to the fourth plus 1,000 meters to the fourth, which equals 1,084 meters to the fourth and 4 significant digits.